So as mentioned in the last video, we don't want to just be able to look at graphs and kind of guess the relationship. I mean, that's lovely, but we want a number that's going to measure it for us. A number that's going to tell us what the strength and direction of the linear relationship between two quantitative variables is. And that number for us is R. R is the sample correlation coefficient, or the linear correlation coefficient, if you want to think of it that way. And if you look at the formula, it's pretty ugly. It's worse than you think. You'd actually have to find the z-score for x and then the z-score for y for every single data point. And then you'd have to multiply them and add them up, etc. We're never going to find this by hand. Never, never, never. We are always going to use StatCrunch to do this. So there's our path for StatCrunch, and we will use that. But what does this number tell us? Okay, so first of all, the number is unitless, just like z-scores. It doesn't have any units, no inches, no feet, no nothing. We usually round it to 3 to 4 decimal places. And the number can tell us the direction, because the direction can be positive or negative, right? If it's positive number, then that would mean you have positive slope, and it means that there's a direct relationship. As x increases, y increases, right? That is a direct relation. Or it could be negative. If it's negative, then that means that as x increases, y decreases. And that's an inverse relationship. So those are the two big ones, right? Positive or negative. 0 would actually mean that there is no relation, which we'll see down below. So that would be the third option right here. So the strength, well, the thing is that R can go anywhere from -1 to 1. And the bigger the value of the number, disregarding the negative or positive part, the stronger the relationship is. So strong relationships are actually very close to 1 or -1. So if it's a strong relationship, you could have a strong positive or a strong negative, but you'll be close to 1 or -1. Weak relationships are actually very close to 0. And all of this is drawn in a diagram down below. And there's also a list if that is better for you. Right? So the strong relationships I have in green out here. So you could be strong positive, which is anywhere from 0.8 to 1, or strong negative, which is -0.8 to -1. Now, 1 and -1 themselves are special. They're actually a perfect linear relationship, which we don't have in statistics very often. You can have a perfect negative or a perfect positive. So these are the perfect ones. They're very, very special. It generally happens in an algebra class when all of your points form a perfect line, I should say. So strong negative and strong positive are over here. And then as you work your way in to 0, 0 is in the middle, which I forgot to put in this diagram, but 0 is right here. So the closer you are to 0, the weaker you are. As a matter of fact, once you get close to 0, within -0.3 to 0.3, it's no linear relation at all. It's so weak that there is not a relation. And then the weak ones are here from the -0.3 to the -0.5, and the +0.3 to the +0.5. And then the moderates are right here from 0.5 to 0.8 on the negative side and 0.5 to 0.8 on the positive side. All right, so let's put this into practice and actually start looking at some relationships. Actually, before I go do that real quick, let me just remind you that a positive relationship would mean that you're climbing, right? As x increases, y increases. So it has a positive slope. And if it's a negative relationship, it would mean as x increases, y decreases. So it has a negative slope. Just a little reminder of what those look like. All right, so let's go look at an example right here. So we have an array of numbers at the top, and our job is to figure out which ones are which ones are strong, moderate, etc. And then we can label them and attach them with their numbers. Now the easiest ones out here are the 1 and the -1, because those are the ones where the dots will form a perfect line. So if you see this one right here, all the dots are in a perfect line. So this would be R equals 1. This is a perfect positive relationship. Right? There's no straying from that line. Similarly, r equals -1, right? So that's a perfect negative, which is this one down here, right? This is r equals -1, and that's a perfect negative relationship. And then me personally, I think it's going to be easiest for us to kind of look at our strong relationships than moderate. The weak ones are the kind of the hardest to figure out. Okay, so if I look at the remaining values, r equals -0.95 is a strong negative relationship. So when I look here, I need to look at negative relationships, and the strength is measured by how tightly clustered the points are to the line. As a matter of fact, we should probably write that. I'll actually write it on the previous page right here. So strength, this section right here, strength is how tightly clustered the points are, right? And of course, in the relationship of a perfect relationship, they're completely clustered on the line. But how tightly clustered along that line is what you're looking for visually. Okay, so let's go over here and let's look. So these ones were perfectly clustered on that line. But I want a negative relationship with the points pretty closely clustered, and it's this one, right? If I look at the other negative relationship, they're way more varied. So it's not those ones, it's this one. So this one is r equals -0.95. The points are very tightly clustered along that line. They're not straying far from that line. So this is a strong negative relationship. Similarly, I want to look for where there's a tight clustering, relatively speaking, along the line in the positive direction. So if I look at the positive ones, which one has the points most closely lined up to that line? Well, it's this one, right? Because the points are pretty close to that line. So this is r equals 0.83. So this is a strong positive relationship. Okay, now what about 0.59? 0.59 is a moderate positive relationship. So the points will be kind of clustered near the line, right? Not perfectly, but it'll be better than nothing. And then -0.44 is not moderate. So we're only looking for a moderate one. So if we look, the positive ones that are left are this one and this one. These two have positive slope. But these points are kind of more varied. These ones, I can still see the trend of the line. I can see the points clustering along the line. So this one's actually the 0.59. And this is what it actually looks like, right? This is a moderate positive relationship. All right, that was the only moderate one out there. The -0.44 is actually a weak relationship. So I need to find a weak negative relationship. So these two are the two negative relationships that are left. So it's a question of which one's doing a better job of tracking. And I think it's this one. So you see how the points are kind of clustering along that line. So this is r equals -0.44. This is a weak negative relationship. And then I'm going to remind you what the two remaining values are. So if you look at -0.22 and +0.11, -0.22 and +0.11 are both in the no relationship zone. Because if you took the line away, if you made that line disappear, it would just look like a cluster of points. There's no rhyme or reason to how these are working, right? If you made that go away, it would just look like a blob. Right, because this is not a good relation. So this is r equals 0.11. I can just tell because the line's positive. So r equals 0.11. So this is no linear relation. They put a line in it, but it isn't valid. This is not a linear relationship. And same thing with here. This is r equals -0.22. This is no linear relation. They are so weak that they're not really linear at all. There's something else going on, or perhaps nothing going on, and there's no relationship at all between the two variables. All right, so let's look at this example, which should not be example 2. Sorry, it's a typo I will fix for future. All right, we're going to circle and label the value for the strongest relationship and box and label the value for the weakest relationship. All right, so when you want to think about which relationship is the strongest, remember that being closest to the edges is the strongest. So being either out here or out here are strong relationships. Okay, so if I look at those numbers, the one that's closest to 1 is actually this one. I'm going to circle this one. This is a strong negative relationship, and it's the strongest we have. Actually, I'll just put that one, right? But it is a negative relationship. All right, now what about the weakest? Well, the weakest would be the closest to 0, right? The closer you are to 0, the weaker you are. So if you think about the strongest, it's close to 1 or -1, right? The negative just means that it's negative, but it doesn't change the strength. When you want the weakest relationship, you want the one that's closest to 0. Okay, so which one's the closest to 0? That would actually be this 0.28 right here. Right? That is the weakest. Right? Because it's so weak, it's not actually a linear relationship.